Hello, yes, I'm back again, here to talk to you about the binomial and the geometric distribution. Now, I'm going to go through a couple of things and I'll give you some nice hints on how to answer these questions. So, we've got the binomial and we've got the geometric distribution. Now, these are vitally important for your exam. Oh, white, that's exciting, isn't it? We'll stick with it. A couple of things that you need to know. The parameters for each one. Now, the binomial, the parameters are stuff that can change each time you use this expression. The binomial has n, so a fixed number of trials. I'm going to have a mirror with this board. So, for example, I'm going to throw a dice 10 times. You know, it's binomial. If I'm going to throw the dice until I get heads, there's an infinite amount of times. So these are worded until you get a success. So until something happens. Now, each one has a probability of a success as P, we'll call it. So the probability of success is P. Now, this means the binomial, is a distribution with B and then your N and then your P. We won't say that together, so we don't like them. So fixed number of trials and then a P. So X here is geo, and because you've got an unlimited amount of trials, you just see it as GeoP. Okay? They both have an expectation and a variance that you can find in your formula book. So it's important to know that these are in your formula book for expectation and variance. I'm going to do the next bit fairly quickly. Now, if we have, tell you what, I'm going to get rid of some stuff here. If we have certain outcomes happening, I'm going to show you roughly how to achieve them, how to answer them. So, I'm trying to smooth a line, because we care about your video quality. So, the first one here is if we have a probability that x equals 5. So we get 5 successes, or we're successful on our 5th go. For this one, you've got 2 options. The best option is probably to use the formula. You get the n trials, and you can use the formula, which is something like n choose, and it'll be 5 in this case. 5 successes, and then we'll do 1 minus the probability, whatever p is and whatever n is, of n minus 5. So these numbers here will add up to n. So I'd use the formula, or you can use the tables in the back of the book. So what you're going to have to do though for this one is you're going to read off at 5, because it's cumulative, it gives you all those less than 5, and then take away the previous one. So take away the probability that x is less than or equal to 4. So that is when you get an equality. As for geometric, if you're successful on the 5th go, we're going to have a fail, a fail, a fail, a fail, and a success. So that is a fail is 1 minus p. Like that was a fail, to the 4, and times your probability, and that's to the 1, isn't it? So use a formula on that one. There's no tables for geometric. Next one. What if your probability is less than or equal to? We'll pick a different number. We'll pick 8. If it's less than or equal to 8, this option is tables. Your other option is to work out no successes, 1, 2, 3, 4, 5, 6, 7, 8, and add them all together. But this one is definitely a tables one, if n exists. If not, you're going to have to do it all by hand. For one of those questions, they were asked that. Here though, for the geometric distribution to be less than 8, what we want to happen is our success to be in one of these trials. So we'll go off an infinite amount of time. We want it to be less than 8. Now, that is going to be 1 minus the probability that x is bigger than 8. Or in this case, it's probably worked better, bigger than or equal to 9. Now we'll look at how to work that out in a minute, because that one is easier to do for geometric. So if we want it bigger than a number. And we'll pick 9, just because we've done before. This one is going to be 1 minus the probability that x is less than 8. Well, less than or equal to 8. Yeah? And if you want to draw your table out for binomial, don't forget this one starts at 0. Now, say we've got 12 trials, it doesn't really matter. Here we want it bigger than 9, so it's 1 minus the probability it's less than 8. So that should make sense. And that, you find it in your table. Now this one here, I can literally work out. If it's got to be more than 9 times, I'm going to have to fail 8 times. And if you're not happy with that, you could do, it's going to be 9, 10, 11 and 12 goes. So 9 goes is going to be 2 fails and a success, plus f to the 9 and a success, plus, well, 10 fails and a success, and this is going to go on forever. Now, if I factorise out an f to the 8, you'll realise that I'm just going to be left with a success, a fail and success, and then everything else. Now, the probability of this happening here is 1. All this is guaranteed to happen. So it's going to be, well, that sequence adds up to 1. So the answer is f to the 8. Now that is how you break down each different part for the binomial and geometric. Just be careful that these aren't equal signs. If this was less than 8, you'd have to replace this here by 7, because obviously 7's the biggest number that is inclusive, and that's less than 8. Hope that helps you. Enjoy your revision.